Good morning and welcome to another JavaScript webinar. In this webinar we're going to talk about TypeScript and Angular. So what are we going to cover today? So first, a quick introduction to TypeScript. So what is TypeScript? Specifically, what is its reason for existence? And then we're going to look at first, looking at how you can use TypeScript in AngularJS 1. And then in a second main topic, we're going to look at TypeScript and how to use it with AngularJS 2, which is right now in beta phase. And then finally, want to wrap it up and give you kind of a quick introduction in how to use the tooling like unit testing, code coverage with TypeScript and Angular. So let's get started. So if you have any questions during this webinar or afterwards, feel free to reach out to us by using the hashtag AskMSDev, and we'll try to answer your questions as quickly as possible. Now, first starting off with an introduction to TypeScript. So what is TypeScript, and why is it there? First, looking at a quote from Anders Helsberg, who is basically the designer of the TypeScript language, and who also participated in designing the C# language. Is that one thing he noticed is that yes, you can write large programs in JavaScript. However, it's really difficult to maintain those large code bases when written in JavaScript. There's a number of concerns there when it goes beyond just a simple couple of pages of web applications or even server-side JavaScript. Very quickly you run into problems, whether it's problems that appear at runtime by having lacking like type checking. So JavaScript is a dynamic language. You can give it anything you want to, but you may run into runtime issues, which are pretty hard to debug at times. And also, well, when you deal with large code bases, managing those individual files and where things are, it becomes really tedious. With ECMAScript 6, some of these things have already been somewhat alleviated, have been made a bit easier, but there are still some concerns, and not everybody is right now running on ECMAScript 6 yet. So there's a number of ways to solve this. Well, the first one, of course, is, well, you're a hardcore JavaScript developer, so you can just bear with the issues that exist and you just crunch through them. That's if you're really a hardcore JavaScript developer. So there's nothing wrong with that. But for the mere mortals among us, there's a number of solutions in dealing with those issues. And they basically are what we call JavaScript preprocessors. So what you do is you write basically in another language, a derived language from JavaScript, and then you transpile or pre-process that language into JavaScript. A number of examples you see here are CoffeeScript or Dart or ClojureScript, Script Sharp, and there's a number of others that exist as well. But basically, the concern we see with using these preprocessors or these transpilers is basically that they force you into, or they kind of make you write your front end or your back end code basically in a different language. You can't just take your existing JavaScript and pre-process it as such. You need to basically migrate your existing code base into CoffeeScript or ClojureScript. So looking at this situation, we kind of came up with TypeScript internally here at Microsoft, and it's been an open source project ever since. And what TypeScript is basically a typed superset of JavaScript that compiles into plain JavaScript. It's kind of the core definition of TypeScript. What is important in here is that it's the fact that it's a superset of JavaScript is really important in a sense that you can take any existing JavaScript file and just transpile it using TypeScript, and basically nothing will happen. You can take your code as is, and it will still be transpiled into the same exact JavaScript code. This kind of gives you the advantage of, well, basically gradually migrating or evolving your code by adding some of the nice features that TypeScript brings you. And we'll look at that in just a minute. So you can really gradually evolve your code where you need some type safety or a more modular approach for your code base. You can add it as you go, but you don't have to rewrite everything just from the start if you want to dive into TypeScript. So that's really a nice feature of TypeScript. And of course, it adds a number of features which we'll look at just right now. So as already mentioned, the key kind of feature of TypeScript, and the name kind of says it, is static typing, which is being added to a dynamic language as a JavaScript. So you can actually define your variables, your function parameters, and give them type information. This kind of makes your debugging experience, or basically compile time experience as well, a lot easier, and even your development experience. And you'll see that at the end here, the IntelliSense and syntax checking can already happen at development time. So your developer tool, your editor, can really help you already while you're writing your code for doing some static checks if you don't have any type mismatches in your code base. So this already gives you a really big advantage. And on top of this static typing, this type safety as we call it, we add a number of features which are really nice for making your code more maintainable, more easy to manage. And so some of those are basically encapsulating your code into classes and modules. Modules which are basically a feature that were added into ECMAScript 6, but with TypeScript you can already use that functionality of modules and classes already right now, even with ECMAScript 5. So you don't really need an application that's fully ES6 supported. You can basically have TypeScript give you those features at development time, while not yet having them while running the application. So you can transpile your TypeScript into ECMAScript 5 or 6, whatever you like, and basically take the advantage of those features that exist in ECMAScript 6. Even some of the features specifically then for Angular 2 that are already coming in ECMAScript 7 are already available for you. So on top of those classes and modules, as you can see here, we provide support for interfaces, enums, properties, etc., generics. All of those functionalities are basically available with TypeScript. Now, enough slides for this part. Let's dive into a demo of how to use TypeScript and the features that are provided in TypeScript. So first off, I'm going to open up here Visual Studio Code with a simple JavaScript file. It's just a greeter.js file. So this, as you can see, it's plain old JavaScript. It's pure JavaScript that you can see here, and this is just to demonstrate that you can just use an existing JavaScript file, run TypeScript on it, and it will still continue to work. So first, where do you get TypeScript from? So TypeScript, you can get it, just go to your command line, you can get it through npm. So just a node package, you can just do npm install. Let's install it globally under TypeScript, and that will install basically the tooling, the TypeScript compiler command line tool onto your machine. So once you've done that, you should have TSC, which is the TypeScript compiler. Let's check our version number here, and we can see that we currently have version 1.8.9, which is the most recent version of TypeScript available on our machine. So how does this TypeScript compiler work? Well, you basically just give it a TypeScript file, and it will generate the corresponding JavaScript file. So to do this, what we're going to do, I'm switching back to code here. I'm going to rename our greeter.ts file into a TypeScript file. So let's make it greeter.ts. We haven't changed anything on our in our file. Now switching back to our command line, what I'm going to do, I'm going to compile this greeter.ts file, and we should oh, of course, I need to be in the proper directory, of course. To our introduction, and in here we should see our greeter.ts file. Let's do this again. greeter.ts. It should be generated, and it should generate now, if we look at, again, into a greeter.js file. Yeah. Now, switching back to our code, you can see if I open this file alongside our source file, so we have our TypeScript file, you can see that the corresponding JS file is exactly the same, so which is to be expected. Now, just to demonstrate, you don't have to do anything to your existing code, just compile it and it will still continue to run. Now, we want to add some of this type safety to our code base. I'm going to add some more space here. So first thing we can do is, you can see when I'm hovering over this user variable, it already detects that it's a string variable. You can see that for strings we have some IntelliSense being added. So we can see how all of the functions available for strings are available to our user variable. So that's just one thing. Now for our specific function here, we have a greeter function which takes into as a parameter a person object. Well, we can mark this input parameter as being a string variable. So we just do it like this, colon, and then we put the string type in here, and that will mark this specific input parameter as being of string. We can also mark the result, the return of a function with a given type, so we can do the same thing here by marking this one here as also a string return value. Okay. So as we do this, we can again transpile our code, and maybe easier than just switching back and forth, we can use the dash watch to keep watching for changes to this specific file. So like this, every time the file changes, the TypeScript compile will continue. So as you can see, we compiled our file and basically nothing has changed. All of the type safety that we add here is not reflected in the JavaScript. It really makes sense because JavaScript, pure JavaScript, it doesn't have the notion of typing, so there shouldn't be anything in here. One thing that you can see now by using this type safety or type checking in our editor, if instead of using this the string value here, let's say we give it a number. So what you'll notice is we immediately get here this squiggly line. It's giving us an error saying that we can't assign a number variable to a parameter which is of type string. So again, already this helps us while developing. And again, we see in our command line as well that the TypeScript compiler says that number is not assignable to a parameter of type string. So you get really detailed information here. You notice still we generate the corresponding JavaScript file. So we still generate the output JavaScript. We don't block you from doing this. You can configure this if you want to using a tsconfig.json file. Let me show you this. So in the tsconfig.json file, I'm opening it here. You can basically specify the parameters for TypeScript to use while transpiling your files. So one of the options that you can give it is basically your target JavaScript version that you want. In here, we're generating ECMAScript 5, but you could just as well use ECMAScript 6 or even ECMAScript 3 if you'd want to. So let's stick to ECMAScript 5. You can specify your module loader. You can also specify if you want source maps to be generated for you, which might be easy while debugging your code in your browser, so that you can get the mapping from JavaScript into TypeScript. And we can specify which files to compile, etc., etc. And there's a whole bunch of other options that are available. So as you can see here, for example, the the experimental decorators, we'll use them for Angular 2. Okay, so let's leave this here and just put our JavaScript file again. So as you can see, we have type safety, but we can go one step further. Let's remove this again. And we can start using basically what we call interfaces. So instead of just passing in here a person object of type string, we can specify an interface which describes basically a person object. And let's do it like this. We have an interface, and a person should have a first name of type string, and it should have also a last name of type string. Again, you'll notice that interfaces are not known in JavaScript, so nothing is really generated here. So your corresponding greeter.js file does not change. Now we can change here the type of our input parameter. Instead of using a string, let's make this a person interface. You'll notice here our type does not match. But also now, instead of using just person, we can now use the properties that exist in this interface. So we could say first name plus something like this plus person dot last name. Okay. So with this, we've kind of changed our implementation. You can see that right now our function in our JavaScript file changes, but it still has no notion of this interface. Of course, we need to change the type of our user object, so we need to specify here something that's compatible with an interface. So we should have first name equals Jane and the last name. Let's specify this one as well. So Doe. So as you can see, we have type compatibility. So we just give it an object which has the right signature. It will pass basically as something that's compatible with the person interface. So this is really nice. TypeScript kind of helps you in that. Now, one further step we can take. So here we just defined an interface of a person object. We can actually create what is called a class. So you can already here, so you noticed we're generating ECMAScript 5. We can already at development time start using classes which have just been introduced in ECMAScript 6. So let's define a class student, for example. So this student class should have like an additional property in it, which is the full name, again of type string. So this will be the combination of the first name and last name. And the nice thing with classes is that you can again already start using constructors. So we have the constructor, and let's create a constructor, and it should have a first name. You can specify the type as well. And while constructing our student, you should also have a last name. You can add additional ones if you want to. Again, last name is of type string. And in the implementation here, when we create a new student, we're going to initialize the full name being the first name plus the last name. So just concatenating first name and last name to generate our full name. So one thing you already notice is in our generated code, classes, they don't exist in ECMAScript 5. So these are being translated into a variable which has a function. We have a corresponding function for the constructor. So this is basically how TypeScript kind of generates the corresponding ECMAScript 5 code that matches whatever you type here in your TypeScript. So if you want to use this one, what we can do is we can create a new variable. Let's say Joe would be a new student. So we're instantiating an object of that class, student. And you can see we get IntelliSense because again of TypeScript we have our editing experience is really enriched by giving us IntelliSense. So we know that we need to pass in a first name and a last name. So we can pass in Joe, kind of crazy name, and which makes it compatible with the person interface. So we can just put it in here, or we can mark our input parameter as of type student. So this is kind of a number of base features that exist in TypeScript. One thing I want to show you as well is how you deal with modules. So we could create a module if you want to make your code more maintainable and split it up in different modules. What you can do is you can create a module, let's say module greetings, just like this. Let's move this one to the back. There we go. And so what we've done right now is we've created a module greetings. If we mark, for example, student as being export. We can export our class out of our module. What we can do is we can create, for example, a student of type greetings dot student. So we mark this object as being exported to the outside world. So for anything outside of our module, this greetings dot student will become available. So this kind of makes your code really maintainable by splitting it up, and we'll see this being used again in the example when I go to the Angular 1 and even Angular 2. You'll see extensive use of modules in there. So this quick introduction to TypeScript. There's a lot more. If you want to learn more about TypeScript, you can just navigate to typescriptlang.org. There's a learning section where you have the handbook, which explains every single feature in TypeScript. There's also a playground where you can try out some examples as you go while in the browser, and so on. So basic introduction to TypeScript. Switching back to slides now. And so as you've seen already in the kind of the simple demo of TypeScript, one of the key features of TypeScript is type safety. And here in AngularJS, while working with controllers, with models, it's having that type safety is really handy. It really helps you and be very performant in writing your code. It really helps you in making sure you don't make any typos while typing or running into runtime issues. So this is one key advantage of adding TypeScript on top of your AngularJS code. And the second thing is the fact that you could really modularize your code base by having the features such as classes and modules, and we'll see that in the demo. You can make use of ECMAScript 6 features while you're still using ECMAScript 5. So again, you don't have to rewrite everything. You can gradually start implementing these features such as modules and classes or interfaces into your AngularJS code base. And as a result of that, you get IntelliSense in your editor. As you've seen, I've been using Visual Studio Code, but just as well you could use Sublime or Atom. So they all have support for TypeScript and IntelliSense based on TypeScript in them. So you don't really need to use Visual Studio Code. You can. It's our cross-platform editor. So it runs on Windows, Linux, and Mac. But know that you can also use other editors if you want to. So let's look at the demo. Kudos here to Tess Fernandez, my colleague in Microsoft, who's built a nice set of blog posts on how to use AngularJS 1 with TypeScript and for putting up a sample application. Let's take a look at the application. So the application that we will be looking at, just a demo application, it's an application called the Mall. It basically gives you a store listing of different stores that you can find in a mall. You can click at a specific mall that's of interest to you, and you can look at the store details. So you'll see when is the shop open, contact details, location inside of the mall, and so on and so on. So just a very basic sample of how to use AngularJS and having some model view controller functionality in there. Okay, so this is what we're going to look at. So switching back to our store listing. Now, what is the code looking like for this one? Switching back to another Visual Studio Code instance. So what you'll see here is we'll have our index.html file, which is pure HTML. You'll see nothing particular apart from the fact that you can see it's an Angular application. Using the ng app mall app, you notice that's basically using Angular for writing the front-end code. Okay, now you can see here we're importing our app script app.js, and this is where that's the starting point for our application, where we're going to instantiate our Angular code. And instead of having an app.js file, as we're going to use TypeScript for our backend code, for our well, our AngularJS code, we'll have an app.ts code, so app.typescript file. Okay, so switching to that one, what you see here is standard Angular code. Apart from, of course, we'll have a module of app. So this already allows us to kind of separate out and modularize our application. So we have our core app module, and we'll see other module being added as we look at other components of our application. But one thing you'll see here is that as opposed to our initial examples where we have all of the code embedded in our application itself, using Angular, it's using external JavaScript library, basically the Angular library, and we'll have Angular and Angular routing and Angular resources. So the root you can see here, and we'll be using resources as well. You notice the squiggly lines. So we don't have basically the type information for these external libraries. So how do we deal with that using TypeScript? So one thing that has been done by basically by the community is there's a project called Definitely Typed. You can just go to definitelytyped.org. In there you'll find a huge repository of TypeScript type definition files, or DTS files, so d.ts. So as an example, you see here jQuery.d.ts. Is basically a type definition file for the jQuery library, and we'll have the corresponding libraries for Angular, for Jasmine if we want to do unit testing. So there's 1,000 plus basic type definition files in the repository. You can just browse them. And so how do we get these type definitions here? Let's stop our TypeScript watch here for our previous example and switch to our next example. What I'm going to do here is go to the scripts folder. How can we get those TypeScript definition files? And to do those, to get those, you need what is called the TSD utility. Again, you can use npm to install -g something like this, and that will install the TypeScript definition tool for you. Once you have it, what you can do is you can go and do TypeScript definition install, and what we'll need is Angular. We'll need Angular routing, and the other one probably route, and Angular resource to get resources from our data service. So this will connect to this definitely typed repository and basically download all of the corresponding DTS files. And you'll see this here. So it's written 4 files, the Angular resource, Angular route, angular.dts, and also which one that we didn't ask for, but which was downloaded as well, is the jQuery DTS file, because there is a dependency from Angular onto jQuery. So it's downloading that dependent definition file as well. Yeah. So where are these DTS files? They are being written. If you to a directory, you'll see once you run tsd, you'll notice a typings directory being added to your current folder. So if we do a directory of typings, you'll notice we have AngularJS and jQuery, and underneath we'll have all of our DTS files sitting. Now, once we have done these retrieved and downloaded these DTS files, if I just reopen, let me close this file here again, and open app.ts, you'll notice that the squiggly lines on Angular have disappeared. When we hover over Angular, we get some information already. So we get help information from our editing tool. You'll notice that if you start typing main dot, we get also IntelliSense for the methods and properties that are available on the Angular object. So with this, we can do under run. You'll notice, and also get some information about what the run method is. You can see overload information. All of this information is coming from this type definition file. So really helpful. So, and you do the same thing for jQuery by using the dollar character. You basically get you get access to all of the jQuery functionality. So you can do $.ajax for doing an AJAX call and so on. So all of this comes with these type definition files. Now let's look at some code here. So we have now the Angular definition files in here. A core concept of Angular 1 and also from 2 is basically the use of controllers. Switching back to our application. So what you see here is our store listing screen. What is this store listing screen? If you route to this one here, it's basically in our templates we have a view, which is a store list view, which basically defines how our screen is going to look like, and it's linked to basically a controller, and it's linked to the store list controller. You can see that we have the Angular notation here for data binding, the title, and having our store name in there, and so on and so on. So if you go to the actual controller for this specific screen, the store list controller, the usual way in if you're not using TypeScript for writing AngularJS, basically what you would be writing here for creating basically a controller for your screen is that you'd do angular.module, create your controller, and the actual controller implementation would then be a function that you pass in here. And then you'd start to write your properties or variables that are being exposed. Basically, you would add them to the scope so that you can bind to them inside of your HTML code. Now, how does this work using TypeScript? So again, what you'll see here in terms of modularization, we're creating a new module, app.stores, in which we'll define basically our controller specifically for stores. And you'll see that we define an interface, the iStore list controller, which has a title and a collection of stores. So here you could see stores is just a variable or a property which contains an array of iStore objects. If we look at, we can go to the definition. So what are these iStores is basically all of the details for a specific store. So you get a store ID, name, location, and so on. The information that we'll be using for binding to in our screen. So switching back to our controller. And then the actual implementation of our controller is a class object. So you define just a class which implements your interface. You don't have to work with the interface, but it's really handy because you can mock, for example, your controller by having a mock object implement the same interface if you want to. So you don't tie it directly into a specific implementation that way. So within here, we're basically going to implement our controller, and so we have a class, we have our constructor, which takes in a data access service. So we are going to retrieve our data from a data access service. Again, here you'll already notice that we're going to use the module syntax. So our data access service is sitting in app.common.services module. So we access it just using this syntax. And then finally, how do you register your controller? It's basically by doing angular.module and then we specify our controller. Very similarly, and instead of in the pure JavaScript, you would have the implementation straight after. Here, we're just linking it to our class that we just defined, which is our controller. So this is a really handy syntax for registering a controller in Angular 1. Now, let's have a quick look of how does this generate, how is this compiled or transpiled by TypeScript. For that, I'm going to the actual corresponding .stores, and then we'll have here store this controller.js file. I'm putting it side by side so you can see it better. So what you notice here on the right hand side, we have our comments still in here, is that, oops, scrolling a little bit too far, and let's put this this one here. So our module is being translated into a variable app with a function defined on it. We have our stores object here specified, so we don't have any notion of the interface. And you'll see here we define our function, which is the implementation of our controller, and then we're going to basically register our controller here and give it the actual function that was specified on top of here. Yeah. So I find that if you come from a more C# or Java background, this kind of way of writing implementations for controllers is much easier to grasp or to start with than this one. So as mentioned, you're not obliged to use all of these classes, but what might be useful for you is that you could use the kind of pure JavaScript syntax for defining your controllers and objects in AngularJS 1, but you could add maybe the type safety, just the type safety functionality of TypeScript rather than adding all of the classes or interfaces or modules. So you don't have to use all of the features. You don't have to write classes and interfaces, but you can, and so you can just pick and choose the functionality of TypeScript that you want to use and that you want to add to your application. And you don't have to use it everywhere in your application. You can use it wherever you want to. So really makes it a phased move to TypeScript very easy. Okay, so this is how you create your controller. And as I mentioned here, we have our data service that we have defined. And let's look at this data service. So let's just, I'm using F12 to go to the definition. So our data service, as mentioned, it has been specified in a separate module again. So really easy to separate your code out. Again, here you'll see interfaces being used. Our data access service is basically, again, a class which implements our iData access service. And you'll notice here in this specific module that we are using the export basically keyword, so that we can expose our data access service outside of this specific module. If you wouldn't do this, the data access service would only be available inside of this module. And as we are using our data access service in our controller to retrieve our data, we need to mark it as an exported class. Yeah. So very similarly, we define a class for our data access service, and then we're going to register our service again by using angular.module, specifying it as a service. And again, our reference is, whereas in pure JavaScript you would give it a function. Again, here we're just referring to our class data access service to register our data access service as a service inside of Angular. So again, very nice and handy syntax here. Okay, so controllers, services, really nice things to add. One final thing I wanna show you here when using Angular 1 routing. You've quickly browsed across it. So if you go to the app.ts file, you'll notice that we have specified here a route config. So what is route config? It's just a function that we specify here, our app.ts, that specifies our routes. So nothing really particular apart from adding some type safety here. We need to get an iRoute provider in our route config. So this really, again, you can see here there's no notion of classes in here for specifying routes. We're just specifying it as a function, as you would do in pure JavaScript, but we're just augmenting it by using some type safety. So we're specifying an interface here, interface which comes out of our AngularJS type definition file. So you don't have to use every single feature if you don't want to. Okay. So this is kind of a quick overview of how to use TypeScript together with AngularJS 1. So introducing some classes, introducing modules, really separating out your logic, interfaces, and of course type safety, really the cornerstone of TypeScript. Now, switching back to our slides. So TypeScript and AngularJS 1 we've looked at. Now AngularJS is evolving, and we're right now in the beta phase of AngularJS 2, which is really well, I've put the R in parentheses. It's really a revolution of the AngularJS framework. It was initially announced in October 2014, and it's really a rewrite of the entire framework with a number of breaking changes. It's still a work in progress, but the team is really evolving really fast. But one key and important thing there is that the Angular team at Google has actually decided to build AngularJS 2 using TypeScript. And it's really been a nice cooperation between the TypeScript team at Microsoft and the AngularJS team at Google. Really, there's been feedback going from both ends, where we actually modified TypeScript and evolved TypeScript based on the feedback coming from the Angular team. So, for example, some ECMAScript 7 features that were added, such as decorators, and we'll see that in just a minute, which is an ECMAScript 7 feature, were added to TypeScript as a result of feedback coming from the AngularJS 2 team. So it's really been a nice working together with those guys. Now let's look at the demo. So maybe important also to mention is that actually Angular 2 and the examples that they put up on their side are really key, and you can get a big tutorial actually only available in TypeScript, which is kind of nice. It really shows how much they've embraced TypeScript. Now, what is the demo application here? I've just taken the stock AngularJS Quick Start application. It's really an application. It's called Tour of Heroes. You have a dashboard with superheroes where you can click on and get the detail, or you'll have the full list of heroes that exist. You can click on one, let's say the Narco one, and it will show you the name. You can view the details of the specific character. So you can see it has an ID and a name. It's really big, really simple, just to demonstrate kind of Angular 2 features. So let's switch to the code and look how TypeScript is really being used here. So another instance of our Visual Studio Code. And let's look at, so you saw the list of heroes being shown there. Basically the list of heroes is being implemented. Let's look at here. If we have our index.html, we see that AngularJS 2, we have a my app tag being added. This one is being registered in our app component.ts file. And one of the things you'll already notice is that first we'll see a number of import statements where we pull in modules and objects from the core of Angular 2. We have a number of files that we've defined locally here as part of our project. So the hero.service, the heroes component, the dashboard component, so all of our Angular 2 components are being defined here in separate files, so we need to import them. And one thing you'll notice here, and this is kind of one of the key features of Angular 2, is the use of these decorators. So scrolling first all the way down here, our app component, so our main component for the application, is really a class. It's a class object. It's being exported, so it can be used externally. We give it a property, but basically the bulk load of the Angular 2 logic is being implemented using what is called decorators. These, as I said, ECMAScript 7 functionality. By using this add sign, add component, we can actually annotate or decorate our class with additional functionality. Yeah. And so the key decorator for Angular 2 components is the add component decoration or annotation. in which you specify basically your selector. So this is going to be the tag that is being used in your HTML. So the my app, as you saw in the index.html, is basically your tag name for this specific component. We can then specify our view part of our component, so the visual part of our component, so the HTML logic. We can specify it inline, and you'll see it afterwards. Also, you can also define it externally in a separate file. So you can use, instead of template, you'd be using template URL, where you have your HTML separated out. Similar to here, your style URLs. So this is your markup, your styling of your markup, so your CSS. Here we're referring to it externally. Could similar to what you have here for your template, could be defined inline as well. And we'll have a number of providers here, which are basically our data services that will give us our data. And so next to our actually component definition for our class, we have the root or routing configuration as well specified in here using a decorator. So core concept is you create a component, which is a class, and you decorate it with AngularJS2 functionality by using these add component decorators. So let's look at an example here of our, let's say, the heroes component. So this one is being used for displaying, let's scroll up a bit, for displaying the list of heroes. You'll see here we have, again, our component is defined as a class, so the heroes component class. It has the add component decorator, which specifies again our selector. So you'll be using my heroes tag inside of HTML to specify the specific component. And then we have our view part being specified in an external file. So the app heroes.component.html defines basically the visual part together with the styling part of our application, of our component. So quickly looking at heroes.component.html. In here you'll notice all of the functionality that you know of Angular and Angular 2. So we can have a for loop where we loop over all of the heroes in this collection. When we select a hero, we'll be invoking the onSelect function. And we are going to specify if we have a selected hero, we're going to display his data. We can go to the detail again using this function. So where are these functions being defined? And these properties such as heroes. Switching back to our TypeScript file, our definition of our component, you'll notice that inside of our heroes component class, we first have a heroes property. So this one is being used to loop over and get every individual hero that's existing in our collection. And then we have the get heroes method. We have the onSelect. So if we click or if we select a given hero in the list, we're going to set the selected hero, which is again a property available. And we can go to the detail by invoking then the router and navigate to that specific detail component for the selected hero. So again, really nice and easy if you're familiar with classes and those concepts. It's really easy to define AngularJS components. So just define your class, decorate it with the visual part, adding the selector, adding some directives if you have a dependency on other components, you'll put that in the directives. But it's really nice to separate out all of your logic by using this functionality. Okay. So this is really briefly how you work with Angular 2 and TypeScript. So switching back now to our deck for some final notes. So this is so what we looked at right now. So we looked at TypeScript. What are kind of the features that exist, and then AngularJS 1 pulling in the type definition files, and then using classes interfaces to write up your controllers, your routes, and so on. And then looked at Angular 2, where we had basically the meat of the application of the Angular 2 components actually being implemented using TypeScript and using classes, decorating them with these add annotations for your classes, tying in Angular 2 functionality to your component. Uh, One thing you may wonder is, well, we didn't put in any type definition files for Angular 2. You didn't see me put in any of those DTS files using TSD. Um, Let me switch back really quickly to show you how it works. With Angular 2, actually what they decided is, because they are so much embracing TypeScript, if you pull in Angular 2 as part of their npm packages, let's look at Angular 2 in our node modules. What you'll notice is that already in there you'll have a typings folder for the different components that they depend upon. So the actual type definition files are part of the npm package, and this is also something that we recommend. If you write some packages, just put all of the type information already in there, so that people get, with a given version of an external library, you get the proper version of your type definition files as well, that go alongside and are sitting in your npm basically package. So tying all that into a single package makes it more convenient for developers to use a library and start using TypeScript, or have the IntelliSense basically that comes with TypeScript. So this is kind of the difference between Angular 2 and Angular 1, where Angular 2 already wraps the type definition files. Now, one final topic I want to cover is kind of the tooling. So you may wonder, so all of this is nice, but how does my existing kind of pipeline for unit testing? Because, well, you write code, you develop code, in between developing and deploying it to production, usually there is some other steps that you need to do, and one of which is unit testing. So how do you do unit testing with TypeScript, and then specifically also here for Angular? There's a number of tools or frameworks that already exist, and basically you should be able to continue to use those tools and frameworks. So, for example, unit testing, you can continue to use Mocha or Jasmine. ShouldSpa is another unit testing framework that you can use, and that basically is going to use Mocha and Jasmine depending on how you configure it. So you can continue to use those frameworks. Angular 2 basically uses Jasmine by default. So if you have the Angular/testing package, it will basically revert to using Jasmine as its unit testing framework. So if you don't want to use that, you can still continue to use or start using Mocha as well. And I'll show you a quick sample of how you can use Mocha as well with AngularJS. Now, one of the things, of course, and what you see here, the test runner is Karma, which is very often being used, is going to really execute your unit tests. And this kind of ties into the last topic here, the code coverage, is if you're using transpiled code, so which TypeScript is, so you compile your TypeScript into JavaScript, how can you have your code coverage match your TypeScript? You want to be able, the same way as you have source maps for mapping if you're debugging your TypeScript based application in your browser. If there's an error happening or you're stepping through your code, you want to step through your TypeScript code and not your generated JavaScript code, because that's not what you've written yourself. The same way, you want to have code coverage which also maps to your TypeScript code that you've written. Are you covering 100% of the JavaScript code, or are you covering 100% of your TypeScript code? There might be some differences because we're generating some code. I think the most often used code coverage framework is Istanbul. And some time ago there was a project, an open source project, which is called Remap Istanbul, which basically gives you this functionality of Istanbul works on pure JavaScript, and Remap Istanbul will basically map using the source mapping information, remap your code coverage report onto your initial TypeScript. So this is really handy. So let's quickly show you how it works. So first thing I want to show you is how to use Mocha. So how to write some unit tests. So in here, I just have a very basic validating set of libraries. So I have here validation.ts. So this is just an interface. And then we can have a letters only validator. So this is going to check are you passing in only letters. And then I have a zip code validator as well. So these are basic functions. It doesn't really matter what implementation is sitting behind it. And then we are defining a number of tests, unit tests written in Mocha. So if you look at sanity.ts, we basically have here our unit test definition. So we describe our sanity tests, which should pass. Of course, 1 plus 1 equals 2. This is kind of a no-brainer, and it should indeed pass. If this one doesn't pass, you have kind of a problem with your setup. We have our letters only validator. Again, here we're using it's .ts. So we define our Mocha unit tests using TypeScript. With again the advantage of being able to use type information. If we were to use, now this is a very basic example, but you could use static typing inside of your unit tests. So running all this, how do we run this? So we specify our TS. What we can just do is we can use, and let me switch back to the proper folder, Mocha. So it should be sitting here. If we run Mocha on our current directory, it's going to scaffold. It's going to look at the entire directory, try to basically find all of the Mocha unit tests and run them. So this is a very basic example. Of course, one thing you need to do, you need to compile, of course, all of your TS files into JavaScript files, but then you just run Mocha on top of those, and it will just run your unit tests. This is the most basic example. Just compile your TS into JavaScript, and then just run your Mocha on top of it. Now, one more advanced way to do your unit testing and have all the code coverage, and for this one I need to switch to another project here, is to use here we have Angular 2 starter project. It's really really simple, a simple project. Let's look at this. Do I have it open here? No. It's basically a very simple to-do application. So let's look here. We have a to-do component, a to-do list component, where you can add a to-do item, you can delete a to-do item, and by default it's going to create two to-do items in your list of to-do items. So we have a class, Angular 2, we have a component with our template URL, so our view for a specific component. Now we can specify our test for this Angular 2s Angular 2 component, and this is specified in the to-do list component.spec.ts. So by using the spec, you should already kind of be hinting at Jasmine, because that's kind of the syntax that is, or the naming that Jasmine is using. So we specify a test component for testing our to-do component. It's a component in itself, so you can see it here. Basically, again, we're describing our unit tests. In this case, we're using just Jasmine. And as you can see, we're instantiating an object. We're adding one, and then we're going to look at do we have 3 items in our list? Because we're starting with 2, we're adding 1. We should have 3. So, and then we're going to check is the last item we've added, is that corresponding to our test item. So this is what we're testing here. Okay. So this is how you test, so how you define your unit test using Jasmine and using TypeScript. So it's pretty defining a component. Now, how do you run all this? So for that, what we need to use is we're going to look at our package.json where we define a script. So in our package.json, we have a test action defined, which is going to run gulp and the test task. If we look at the test task in our gulp file, what is this one going to use? The test task is going to execute first, it's going to clean up stuff, and then it's going to execute the unit test task. So this one is going to start up a server, which is basically the Karma server. So our test runner is instantiated using this Karma configuration file. It's going to run it. Once it's done, it's going to do the remap coverage, which is basically inside of our karma.conf file. We specify run the unit tests, then afterwards run code coverage using Istanbul, and then finally the remap coverage is going to take the output of the Istanbul code coverage file and just remap it into an HTML file and map the JavaScript calls into our original TypeScript calls. Now, what is the output of all this? I'm not going to run it just for the sake of time. Once you've done a npm run test, you'll get a code coverage report generated for you in a HTML, could be JSON as well. And looking at our app.to-do list, we see that we have 100% code coverage. We can drill down here. Our to-do model TypeScript file has been covered for 100%. We can drill down, you can see our original TypeScript code. To-do list component TypeScript file. Again, we have 100% code coverage for our original TypeScript code. And this is really what you wanted to see, is code coverage of your original TypeScript files and not necessarily the JavaScript file that was generated as a result of your TypeScript transpilation. So with that, I think we've covered all of the topics. There's a lot to cover in a 1-hour session. I hope you've got some interesting tips here and got some introduction how to use TypeScript together with JavaScript with AngularJS, whether it's version 1 or 2. And so as you saw, Angular 2 is really TypeScript really using TypeScript at its core. And with the tooling, know that you can continue to use all of the unit testing frameworks and code coverage frameworks that exist while using TypeScript, so you don't have to step away from using those tools just because you're using TypeScript. A number of resources that you'll find here. We'll be uploading the deck as well alongside the recording. So this session has been recorded and will be put on channel 9. Once again, kudos to Tess for providing the model sample and a series of blog posts which you can find at the address specified here. If there's any more JavaScript of these webinars following over the coming weeks, now we've got the build conference next week, so we'll have a short break in between the webinars. But just check out aka.ms/js webinars, and you'll find a few more of our JavaScript webinars coming up in the following weeks. If you have any more questions right now or later on, just reach out to us using Ask MSDev. And with that, I want to thank you for joining this webinar, and hope to see you soon.